Alright, welcome back to Freestyle Visual Scripting Crash Course. We're working in Unreal Engine, we're working with blueprints, and we are working on giving you the foundational knowledge that maybe you didn't have if you've never taken a scripting class or you don't have a software engineering background. Today we're talking about branches and booleans, and I am probably going to get even more excited with each of these new classes because we're getting more and more pieces that we can work with to make all of our visual scripts that much more powerful. In this case, this is kind of a twofer on the class. We have our branches. We're going to be talking about control flow, and we are also going to be talking about a little bit of addendum for booleans because it's important to understand something. So first, let's talk about what a branch is, and then we'll hop into Unreal. A branch is the first of our control flow, sometimes called flow control in Unreal. It allows us to make decisions in our scripts, and it's really based on whether or not something is true or false. If you can ask yourself, is something true or false, you can understand how branches and the flow control works. So if I have ammunition, I'm allowed to shoot. If I have health, I am not allowed to pick up a new health pack. If 5 is greater than 7, do something. Those are all if statements. So let's hop into Unreal and talk a little bit about how we're going to use those in our visual scripting. So here we are, we're in our My House BP. I've just disconnected begin play. And what we're doing, if you haven't been following along so far, that's okay. All you need is a blueprint that has a begin play and just be able to play an actor in your level and you'll be good to go. But we have begin play, and what we are going to do is we are going to create a branch. So in order to create a branch, let's right click and just type in the word branch. You'll see it under flow control, and it's called a branch. Now, the anatomy of this branch statement is we have our input and we have two outputs, and you'll notice we have one path for true and we have one path for false, and then we also have our condition. So in its simplest state, if I were to connect begin play and I put in our good old-fashioned print strings, and let's just say EA true, and I'm going to change this to green, and I'm going to give us 5 seconds so I have time to read it, and then I'm going to duplicate that and we'll go with good old-fashioned solid false. Okay, so we have a solid false, and we'll make that red just so it's very distinguishable between the two. So right now, this is almost the simplest way to use a branch statement. We begin play, it comes in, it says, is our condition true? Is it checked? Yes or no? If it's true, we're going to say yay true, and if it's false, we're going to print solid false. Now, in this particular case, the branch statement is starting off with a check mark, meaning it's true, so we should see green print on our screen. There we go, yay true, awesome. Now let's go ahead and uncheck our condition, which now means it's false. There's no value there, it's not true, and we should see our red print. So you'll see solid false. Okay, perfect. So this is the simplest use of this condition. Now let's use a couple of numbers to make this a little bit more interesting, and we're going to connect to the condition to decide whether or not to make the decision as to whether or not we follow the true path or the false path. So in this case, what I can do is let's just use simple greater than or less than. Okay, if I type in, if I right click and I type the greater than sign, you'll notice that a greater than symbol appears, and I can click on these pins to change what kind they are. So I'm going to right click and I'm going to convert these pins to, let's do integers. All right, the minute I do that, they both pop up. Now, if I type in 7 and 3, you should be hopefully saying to yourself, is 7 greater than 3? The answer is yes, that 7 is greater than 3, that is true. And in that case, we can connect the output to our condition. So now we no longer have to check the box, and basically all we're doing is we're saying, okay, we're checking. Is 7 greater than 3? Yes, it is. That's true. We're going to follow the true path. If we play our level, you'll notice that yay true prints. Perfect. If we change the second to be 13, is 7 greater than 13? No, that's false. So we're going to follow the false path. In this case, we're going to print solid false. So let's go ahead and do that. And you'll see solid false in the top. Perfect. Now, what about 7 greater than 7? Is 7 greater than 7? No. So this should print false. But hopefully you're thinking to yourself, oh, but I remember there when I, was doing stuff in school, there was a greater than or equal to when I learned about all these operators. So yes, there is. If we right click and we choose greater, there is also a greater equal. Same thing, I'm going to right click. By the way, this is a new thing, I think starting in Unreal Engine 5. If you have previous versions of Unreal, you may not have to convert this pen, but in general, if we right click and we change this to 7 and 7, we can just delete this old one. Is 7 greater than or equal to 7? Yes, because 7 is equal to 7, and now we are going to follow the path of truth. And in this case, we are going to print yay true. So a branch allows us to follow the path of truth or the path of false, depending on whether something is true or false, the condition. In this particular case, we have been using greater than or greater than or equal to decide whether or not the condition is true. However, there's lots of different conditions. We can use greater than, we can use less than or equal to, less than, etc. We can even use do objects exist? Is that a true statement? And we can also use Boolean. Now, what do I mean by Boolean? Well, what I can do is, for example, here is a Boolean called in air. If I connect in air to my branch, now it will look at what the value of this is. And if you'll notice, if we compile our blueprint on the right, is in air is set to true. So if we play this, you'll see it print yay true. If we come back and I uncheck this, exact same thing. If I print this, it's going to be solid false because it's following the path of false, because is in air is false. So this is where we start making decisions. For example, pretend that this was your character's ability to jump. If you're in the air, you probably don't want to allow your character to jump again, unless you're doing double jumps. So if you check to see is the character in the air, and it's is in air is true, no jumping. If it is false, then the character is able to jump again. So those are just some examples. Another great example is, can the enemy attack? What kinds of things would allow an enemy to attack? Do they have enough health that they should be attacking? So is the enemy healthy? If that's true, attack. If not, run away. These are the kinds of things that we use branches for. Whether something's true or false, we can choose the true or false path. Now, I want to show you another quick tip for using branches just before we move on to the second part of this discussion, which is all about Booleans. If we want to create a branch, as I mentioned before, you can right click and you can type branch. But my favorite way to create a branch node or control flow node is to hold the B key and left click, and then it'll just pop up. It's a lot faster. So I love this hotkey, B and left click, the branch will pop up and you can connect it up as you need to. So one quick tip before we move on. So what do I mean as far as Booleans? Well, there are some important things to understand about Boolean. Now, let's take an example of what I was talking about as far as maybe we're working with our enemies and maybe we're trying to decide whether or not they can attack. So let's create a couple of Booleans here. We're going to go Boolean is healthy. Is healthy. Now, how healthy gets set or not, let's not worry about that. It's just maybe there's some function somewhere that says if the enemy's health is more than 50%, they're healthy. They're considered healthy. All right, let's create another Boolean called Boolean has weapon. Okay, so what we're going to do now is we're going to use these two variables to decide whether or not our enemy can attack. So starting with the basic, we'll keep our prints here. Okay, first thing, let's just decide based on 1. So the first thing, the most important thing about whether or not an enemy can attack is whether they have a weapon. So if I just take my weapon and I connect it in, just like before, we have a simple Boolean. So if the enemy has a weapon, then it's true. But let's do attack. And if it's false, find a weapon. Or let's just call this don't attack. Don't attack. All right. And I'm not even going to press play because I'm thinking you already have this. So if has a weapon is true, attack. If not, we're going to not attack. However, this is what we've been doing so far. There are some special operators that you can do with Booleans. One of those operators is called an AND operator. So what else might we use to decide whether an enemy can attack? Well, what if, like I alluded to earlier, what if we check to see if they have a weapon and they're healthy? So let's do that. So let's drag this in here, we'll get healthy. How do we do an AND? Well, if we drag off of has weapon and we type in the word AND, you'll notice under math for Boolean, there's an AND Boolean. Now, if we connect both of these in, what is going to happen is it is going to check that both of these are true. So if has a weapon and is healthy, then this will be true and we will attack. Otherwise, we won't attack. So let's take a look at what our defaults are right now and see if we can determine what's going to happen to start with. So the default value for has a weapon is false, and the default value for is healthy is false. So these are both false. So is false and false true? No. False and false is still false. So we're not going to do anything. So we should print don't attack, don't attack. Let's just go ahead and look at that. We see don't attack. Perfect. Now let's come back and change it. Let's say the enemy has a weapon. We're going to change the default to has weapon, and we're going to check that to be true. We're going to compile that. So now when we come in here, we have a weapon, but is healthy is still false. So do we have a weapon and are healthy right now? No, we don't, because we're not healthy. So this is still false. It has to be both. Both of these things have to be true. And if they are both true, the result is true, and then the condition is true, and we go. So right now we have a weapon, but we're not healthy, so we don't have both. Now if we change, and if we run it again, you'll see the red don't attack. All right, now let's go back. Let's change healthy to be true. So now we have a weapon and we're healthy, just like the name of the Boolean math operator and. So I have a weapon and I'm healthy. This is true. So this is going to evaluate to true, and we follow the path of truth, which gives us attack. So now when we compile and we play, we should see our green attack, and we do. Now, there is no limit to the number of Booleans that we can AND together, effectively add together. If I wanted to say, do we have a weapon, are we healthy, and do we have ammo, for example, I could create another Boolean called has ammo, and I can connect that in by adding another pin to this AND statement. So now all three of these, oh my goodness, it crashed. Okay, so we recovered from that crash real quick. So all three of these now have to be true. Our enemy would have to be healthy, they would have to have a weapon, and they would also have to have ammo. Right now, is healthy is false. Let's set that to true. Our default for weapon is false. We'll also set that to true. And right now we have ammo is false. So this is all going to be false, and it is not going to follow the path of truth, and it will print solid false. If we then change and update has ammo to also be true, then we will print the true, and you'll see it print in the top left, yay true. Okay, so that's one way that we can add Booleans. We can AND them to test to see if all of these things are true. This is usually referred to as Boolean math. Okay, now there's another thing we can do with Booleans, and this is called, we could do an OR statement. So let's simplify this a little bit. Let's say that let's say that our enemies can melee or they can attack if they have a weapon, and healthy doesn't matter or not. So if they're healthy, they could attack because they're melee, or if they have a weapon, they can attack and health doesn't matter. In that case, you just heard me say it. If they're healthy or they have a weapon, that's how I know I want to use an OR. So if we drag off of here and I do an OR, you'll see an OR. Now, what this checks is if either of these are true. So is a character healthy or does the character have a weapon? That will return a result of true. So right now, character, let's change both of these so you can see this working. So right now, is the character healthy? It's set to false over here on the left. Does the character have a weapon? No, they don't. It's set to false. We are going to follow the path of falsehood. So there'll be solid false up here. Okay, so now, is the character healthy? Yeah, okay, we'll just check that box, and if we print true, or I'm sorry, if we run, it'll print yay true. Why? Because is healthy is true. It's healthy or has a weapon, and we could flop this. We could set healthy to false, and we could set weapon to true. So if either of these two things are true, it is going to result in it being true. That's why it's called OR. And you can think about it. Are you hungry and you have money? Then you buy food. Okay. When you say it out loud, if it's an and, am I on the ground and I'm running? I can double jump. If I'm in the air and I'm moving faster than a certain speed, I sprout wings. If I am in the air or I just finished running, I can double jump. And I just said or. So that's how you kind of can start to figure out which one you can use. Now, there are other operators that we can do on Boolean. I believe it's going to be under is it math? Let's see where this is. Where does this stuff list? This lists under math for Boolean math, which is variables, nope, utilities. Hold on, let's see if we can find where this is real quick. Hold on. Here we go, math, Boolean math. These are all of the different types of Boolean math operations that are available. Now, I'm not going to go into all of these. The two that you will probably use the most, there's three you're going to probably use the most. We'll cover the last one here in a second, are and OR. NAND, NOR, and XOR, it all reminds me of digital logic. We could probably do another addendum on these. I actually have never used any of those other ones in Blueprint so far that I think of, largely because it's easier for the person following, whoever else has to pick up your stuff, if you're using the more straightforward and or ORs. Now, let's talk about the last one that is important to understand, and that is called the not statement. So, is our character healthy? True or false? Well, what are we going to do? So if our character is healthy, let's say attack, for example. And if not, let's run away, as an example. So if is healthy is true. So if we're healthy, we'll check true, the character would attack. And if we uncheck this, the character would run away. However, what if we needed to say, let's just change this. Let's say we're going to pick up health. And this one's going to be attack. I flipped these. So how do we handle this situation? Well, there's a couple ways to do this, and I'm just going to disconnect some things and show you some logic here. So, is the character healthy? If that's true, I'm going to attack. Okay, this is one way to do it. If that's false, I'm going to pick up the health. It's one way to do it. But you don't always get a chance to choose what you want to do, true or false. So how do you flip a Boolean and make it the opposite value? That's where we're getting to. That is called a not. So if I drag off of here and I type in not, you'll see this not Boolean. What this not does is it changes the value of whatever comes in to the opposite. So if is healthy is true, it's going to change it to false, and that will be what we test against. If healthy is healthy is false, it's going to change it to true, and that will be what we test against. So if is healthy is true, this changes to false, meaning we're not healthy. That's where the word not comes from. So if we're not healthy, we want to pick up a health pack. And so I'm going to flip these back. And if is healthy is false, and the opposite of that is true, then what we're going to do, I'm sorry, I said that backwards. This is why this is so much fun. Okay, starting again. So if we're healthy, if that's true, the opposite of that is false. So what that means is we're going to attack. If we're not healthy, the opposite of that is true, so we're going to pick up a health pack. The thing to note here is, and this is why I wanted to talk specifically about the Boolean variables addendum, that's why I think it warrants a little chat about this, is because this whole and the or thing and this not thing, it's fun to wrap your head around, and it's perfectly normal for you to sit here and go, okay, hold on, not healthy, not in air, not on ground, and then think about the opposite and do that. And this is why it is really important that you name your Boolean variables something that is very clear. Okay? By saying is grounded, is in air, is healthy, has a weapon, it's very clear what that is. So, for example, if we wanted to say, do we have a weapon? How are we going to do this? So if we have a weapon, we're going to attack. But let's just say I couldn't change these paths. But we need the opposite, because for some reason attack is connected to false. So I would need to negate it. So if has a weapon is false, then when it comes into this not, that becomes true and we pick up health. If we have a weapon and it's true, and we change it to false using the not statement, we will attack, because we do have a weapon and we want to follow the path of falsehood so that we can attack. So this is all about flipping the value of the Boolean expression. So we can do the same thing with integers. So for example, we were talking about the greater than before. If we change this back to an integer, let's say that we say 5 and 10. Is 5 greater than 10? No, that's false. So we would follow the attack route. But what if we wanted to follow pick up health? What we can do is we can put the not in here, not Boolean. And so is 5 greater than 10? That's false. But then we're saying not, in other words, the opposite of that, which becomes true. So we're going to follow the path of truth and go pick up health. Now, the point here is not whether or not we're picking up health or attacking or etc. The point here is to understand that in addition to doing and or, and I think those are usually pretty clear, people understand those pretty easily. This not, just know it's available. All it does is flip the value of the Boolean. So if it's false, it changes it to true and true to false. But as you can see, the use of these can start to get very confusing very quickly. So a lot of times, the reason that these get used is for a cleanliness thing. Let's say that for whatever reason, we had attack connected to false. Generally speaking, it is more readable to choose true instead. So for example, we have this. true instead. Okay, but let's just say, let's create a new Boolean that's a negative. Is wounded. Okay, so if we're wounded, we don't want to attack, but we want to keep this in true. So how do we fix that? Because we could say that we could basically, in this particular case, a lot of times you'll see, and there's nothing wrong with this. It's literally just a blueprint best practices and preference thing based on the production that you're working on. So if is wounded is false, then I can attack. But a lot of times, just for clarity, people will say we'd like to connect to true. And when you do that, you have to use the not to flip this. So in other words, if we are not wounded, then we can attack, and that makes it true. So a lot of times you'll see this used just to stay with the path of truth. There are a lot, but bottom line, knots can get kind of crazy in your head trying to track them, and it's not uncommon for me to sit down and write down all of the different options. Okay, especially if I have more than one thing, if I'm dealing with enemies. Are they healthy? Do they have weapons? Do they have ammo? And do they have a target? So now you're juggling 4 things, and maybe they're healthy, but they don't have a target, and where they're not, etc. So don't be surprised if you still, even if you completely understand that all it does is flip the value, you still are going to have to write it down to understand which path you're going to take, the path of truth or the path of falsehood. So that wraps up the first of our flow control options. In this case, it is called the branch. In traditional scripting and programming, it's usually called an if statement. But so if something's true, do a thing. If it's false, do another thing. In this case, it's a branch. So based on the condition, we're going to do true or false. If you are new to visual scripting, Unreal Engine, blueprints, etc., throw some comments down in the feedback below. Let us know how this was. If you're a guru, you're an ace at all of these things, and you think that there are things that we could have covered a little bit different, we'd love to hear from you as well. As always, thanks for checking out the video. If you like what we're doing here, help us out, spread the word. You know how to do that best, so support the channel any way that you know how. My name's Kevin. Thanks for hopping in, and we'll catch you on the next training class. Take it easy.